Using a bandsaw, I cut the end of the board off on the 8th hole. That means I should have 7 holes left. Now all I need to do is file the edge of the board. Next thing to do is take a pad of Scotch-Brite and clean the contacts. These are clean. You don't want to use sandpaper. It'll just eat up all the copper. You can see this board is filthy on the back. Now what I want to do is solder a 40-pin connector. This would be the top. And there are no holes on either side. I wanted to show you how to remove a socket, and my camera stopped. But basically, I need to move the socket that was here, and all you do is take the dikes and chop it up, and then all you're left with is the pins on the board. So I can grab like 3 of the pins, put some heat on them, they come off. Like that. You can see it's coming off pretty fast. To tease that one out, I'll just grab it. Well, it's not too important. Anyways, so now I have to put the socket up here at the top. I finished wiring up the board. This is for the PIC processor, programming, power indicator, test LED, and these resistors go for the LED, and these jumpers go for the LEDs. So to enable the test LED, you need to put the 3 jumpers in. That connects them up to the pins. Just a power on check. Now that the board is all wired, I need to check the voltages that will be applied to the chip. The easy way to do it is stick a capacitor in the circuit. So those check good. The only thing left now to do is to put the chip in the circuit. Now that would have been a problem if I would have pushed it down. Next step, got to make a blinky light program. My test program is written in assembler, and it's set up for PIC16F1519. The configuration is set for internal oscillator, and the watchdog timer is turned off. All the other settings are the default settings. Constants that I set up are the counter 1, counter 2, timer 1, timer 2, bit_e. Program starts at location 0. In bank 2, it clears the latches. In bank 3, it clears the analog select. In bank 1, it determines whether it's an input or an output, and I set them all to outputs. The next thing it does is it determines the frequency. It's set up for 2 megahertz. It then sets it. It switches to bank 0. It starts the loop. First thing it does in the loop is it determines what bit is turned on. In this case, I'm only looking at 1 bit at a time. So it looks at the bit and it says, is it on or off? And then it'll turn it on or off, and it'll run through the loop, which will delay it. And then it goes back to the beginning of the loop and runs again. This is basically the program. Now I'll go ahead and show the device being programmed. I'm now sending the program for port E bit 0. I'm now changing it to bit 1. I am now changing it to bit 2. and all 3 colors lit. So that concludes this test, and I want to thank you for watching.